Welcome to Modular March. I'm Andy, this is Robbie, and we are The Rollup.
Modular March is an educational experience about all things modular. Enjoy.
Welcome back to another episode of Modular March. Today we have Modularity is a Meme, 3 dots, from Togruhl Maharamov, a contributor from Scroll and a big researcher in the space. Togruhl, you've been doing a lot of technical research and kind of trying to push the boundaries for Ethereum scaling. So I'm excited to understand your perspective on modularity today, and welcome to Modular March.
Hello. Thanks for having me. Yeah, I'm not sure if I would consider myself to be working directly on scaling. I mostly just spend time arguing on Twitter with other people about definitions. I'm not sure if that counts as a contribution, but yeah, in a very, very optimistic framing, I think I do contribute. But yeah, I don't want to be considered to be the contributor.
Nah, no worries. I think you're going to contribute to the current narrative and meta of modularity with this presentation. So when you're ready, let's dive right in.
Perfect. Yeah. So as Andy said, my name is Togruhl. I'm a contributor at Scroll, and today the title of my talk is Modularity is a Meme, and so is everything else. So you might have heard about modular chains or modularity. All hail our king, Nick White. And you might have also heard about monolithic chains, or as some people call them, integrated chains. And I present our protagonist today, Kyle Salami. So what makes a chain modular? So I'll refer to a Celestia blog to define what a modular chain is, even though I don't completely agree with the definition, but let's take it as a starting point for now. So a modular chain is a chain that basically has a chain that has the following 4 functionalities, and I'll define how we define a modular chain based on those functionalities. So first functionality is execution, and execution is a process of transitioning the state through user-generated messages. So let's say a user creates a transaction, sends it, the protocol processes it, updates the state. So, and by state, I mean a union of all the accounts of all the users and smart contracts. And once the state is updated, that's called the state transition. Then there's settlement, or the correct definition would be validity, but Celestia uses settlement. And settlement is the process of enforcing proposed state transition. Because let's say if I propose a state route that is an outcome of a certain state transition, it might be the case that that state transition is incorrect and was invalidly computed. And so validity or settlement allows us to basically enforce that state transition was actually done correctly. Then there's consensus or ordering, which is the process of reaching global agreement of all the nodes in the honest nodes in the network on a specific ordering of transactions, which means that if you have like a sequence of transaction A followed by transaction B followed by transaction C, once the consensus is reached on that sequence, you can no longer reorder it later and say that transaction C came before transaction A. And that's important because let's say if you are using an AMM and you want to settle at a certain value, if later somebody is able to come in and say, oh, actually, my transaction with the same AMM pool settled before yours, your transaction can no longer be valid, for example. Or there are a lot of other cases in which ordering is very important. And then the final property is, functionality is data availability, which is the process of making data accessible to any interested party for some predetermined amount of time. So let's say a month or 10 days or whatever. It depends on the protocol. And when I say data specific, I mean data that is sufficient to reconstruct the state of the protocol. So that can either be transaction data, compressed transaction data, or state diffs. And all of them allow you to reconstruct the state. And so Celestia defines a modular protocol as the one that at most enshrines 3 out of the 4 aforementioned functionalities. So let's say execution, data availability, and ordering, and settlement goes somewhere else, for example, or something else. And then, as opposed to that, a monolithic protocol is the one that enshrines all of the aforementioned functionalities. So, makes sense, right? Right? Well, it's not that easy. Celestia already has minimum viable execution. So, because Celestia needs to track the balances of the TIA token and the stakes, and the staking process of TIA token, it has this minimum viable execution that requires that basically is needed to track those balances. And Celestia is already considering enshrining zero knowledge proof verifier into the core protocol, which means that they will be able to enforce validity and therefore allow settlement on Celestia directly. And so now Celestia has the following functionalities once the zero knowledge proof verifier is adopted. It's execution, validity, ordering, and data availability. Confused? A bit? Yeah, I guess. I am confused personally.
And
So,
and I put
it's
out a
Celestia
tweet saying, Solana isn't Ethereum's biggest competitor, it's Celestia. I'm not sure that they're trying to push that narrative themselves because, my Ethereum alignment, but it's really interesting that you bring this up.
Well, we'll see. I have a point about that later. So, is Celestia monolithic? Has Nick lied to us? Not sure. We'll have to ask him. And then, so the answer is no. And the reason why Celestia is still modular is because, as I said before, I would need to expand on the definition of modularity. As long as the vast majority of the execution is outsourced, so what I mean by vast majority is like most of the user-generated transactions are outsourced, modular protocol can retain some capability to do minimum viable execution. For example, in Celestia, that would be to track the balances of of TIA, and then the staking and everything else related to TIA. In Ethereum, that would be that plus facilitating communication between different L2s, etc. And so, but as you can see, the lines are blurring. And let's go a step further and blur them even more. So what if we modularize ordering into ordering proposal and ordering consensus? By proposal, I mean block construction, and by consensus, I mean what I defined before as ordering, reaching an agreement on a certain number, on a certain sequence of transactions. And for example, in Ethereum, most of the validators already do that. They outsource block construction to some specialized builders, and then they just propose the block and reach the consensus, meaning that the block construction, the ordering itself is done by other entities, and then the full nodes in the network, the validators, actually just reach agreement on the work that was done by external parties, which are builders, which means that you essentially modularize ordering into 2 parts, the building and the agreement on the sequence that was built. And Solana validators can do that. And what if they do that? What now? Is Solana modular all of a sudden? Has Kyle lied to us? I don't know. I mean, again, same question as before. The lines keep blurring. And the answer is no, even though I'm not really sure if the answer should be no. But for now, let's assume that it's no. It's a no. And by the way, Kyle hasn't lied to us, but only on this specific claim. Usually he does lie. So, do modular protocols scale better than monolithic protocols? Well, yes and no. So, a lot of people think of it this way: because you outsource certain properties and certain functionalities to other networks or third parties, you might think that actually the core becomes lightweight. But if you think about it, from the overall construction, it's not that simple. And so, like, for example, one benefit of modularity is then you can make the core protocol, so let's say in this case Ethereum, for example, very accessible in terms of the hardware requirements that you need to run the full node, which means that a lot of people can verify the chain themselves without relying on Infura or any other RPC provider, or like all the broken light clients that we currently have. But then we also introduce additional overheads, both on the protocol and the application level. So for example, on the protocol level, you would have to run 2 mempools, you would have to have dedicated searchers for L2s, etc., etc. And on the application layer, for example, if Uniswap wants to support all the major L2s, and assume that there's a world where there are 5 or 10 L2s that are equally as popular as one another, and Uniswap or any other application would like to support all of them. So now they have to have this additional overhead of making sure that they're up to date and everything is fine on every single protocol, and keeping track of the security updates, etc., etc. So there's some, to a certain degree, significant overhead that is introduced. And so from one perspective, yes, you make it more scalable from the perspective of you keep the core very light, and then outsource a lot of heavy work to third-party protocols without losing a lot of trust assumptions that you have within the core protocol. But then on the downside of it is that you introduce additional overheads on a few different layers. And so I think the future it looks more like modular chains will just enshrine more features, and monolithic chains will modularize more features, as I said before. And so the paths are somewhat converging. And at the end of the day, with sufficient abstractions, the two will be indistinguishable to the majority of users, which means that from the perspective of a user who doesn't care about full nodes, etc., most of the problems can be solved on the UX layer. And then everything else is kind of hidden behind, and the only people who would really care about it are devs and very technical users. I don't think I would expect my friends or my parents to care about that stuff. Yeah, that's it. That's it to my short presentation.
That was so much fun. I think one thing to consider is that the definition, and Togruhl, since you're a definitions guy, like I figured frame it in this way, like the definition of monolithic is so strong, and the definition of modular is so loose that the modular guys are in a position where if anything is modularized, whether it's just something as niche as ordering and like proposer and builder separation, for instance, in ordering of Solana transactions, all of a sudden you call the entire Solana thing modular, because that modular definition is so broad that anything modular in the entire stack now makes that entire chain modular. So like yeah, it's just something worth pointing out, I think.
Yeah, I agree. I think monolithic is more of a binary concept. You are either monolithic or non-monolithic. It's just a question of where you set that line of when you become modular or when you still monolithic. Whereas modular is a scale. Basically, you can be completely modular and separate every single aspect of the protocol into different components and different protocols, or just have one thing separated. Like, for example, in Ethereum, you only separate the majority of the execution, and then everything else is still enshrined, but you're still modular. So and that's the reason why I think a lot of the definitions that we currently have are more of memes rather than actual definitions, because it's like so difficult to define what is a monolithic chain or what is a modular chain.
Does that make Ethereum modular by the definition of like separating most of the execution off to rollups? And
I would say so. I would say that Ethereum, by my personal definition, again, Celestia people will definitely disagree with that. Ethereum is to a certain degree modular. Is it sufficiently modular enough where you can actually consider it modular? I don't know. Will we ever get to a point where no apps are running on Ethereum and everybody just uses L2s? Maybe, I'm not sure. There might be certain use cases that will require L1s, for example, and that will disqualify Ethereum. But in general, I think I think you can make the definition loose enough where Ethereum becomes modular.
Yeah. Could you go back to the slide where you showed the definition of the 3 of 4 parts? I think it was close to the beginning. Because this was a definition that I haven't heard before, but I'm not sure. Yeah, okay. So modular protocols at most enshrine 3 of the 4 functionalities, and that's what makes a project or a blockchain modular. Is this your definition, or was this from the Celestia docs?
So it doesn't directly say that, but based on all the documentation that they have, they separate the scale. They have this table where they have the 4 functionalities, and then they show that Ethereum has these functionalities enshrined, and these functionalities are not enshrined, etc., etc.
Yeah,
and based on that, I basically derived the definition. But I would say, if you ask the majority of people and like present those functionalities, I think the majority of people who work in this space will agree that if you can at most enshrine 3 out of 4 functionalities to be considered modular.
And I think like where we got to is like, what if you have 3.5 out of 4? Are you still modular?
Yeah, exactly. That's what I'm saying. So even Celestia has minimum viable execution. Even though they like to say that they outsource execution, there's still some execution being done by Celestia. And so once they introduce the zero knowledge proofs, is it actually modular? That would be funny if like the pioneer of the term stops being modular and becomes a monolithic chain.
So let's talk about that. Is Celestia more of a potential competitor to Ethereum than Solana if they implement this ZK verifier?
And could you explain like what Celestia's current like vision is when it comes to ZK? Like, how are they going to incorporate ZK verifiers into their stack?
So there have been discussions about it for quite a while. At least I've been hearing about them in private circles about like, if you can enshrine the prover, the verifier directly into the protocol. So essentially, you would have a let's use Ethereum terms, an opcode that would verify a snark, for example. Let's call it verify snark or whatever, and then that will allow you to basically have trust minimized bridges, because right now there's no way you can have a trust minimized 2-way bridge on it. On Celestia, you can go from Celestia to a rollup in a trust minimized way, but you cannot come back. So you need some form of a verifier to do that.
What does trust minimized mean in this context?
So trust minimized, again, there's no concrete definition. As with everything else, it's another meme. But I personally define trust minimized as a protocol that doesn't require an honest majority assumption. So basically, which uses a 1 out of n or a weaker assumption. So that would be either fraud proofs, which require a 1 out of n where n is unbounded, or zero knowledge proofs, which don't require honesty assumptions at all. It just make like mathematical correctness assumptions.
Got it. Okay, so like unconditional, essentially, in terms of honest actors on the system.
Yeah, basically the weakest possible assumption you can have in terms of honesty.
And that's possible in a one-directional bridge from Celestia to some rollup, but it's not possible to go from a rollup back to Celestia in that very like weak assumption where there's so many dishonest actors. It's not possible to go from a rollup back to Celestia in that trust minimized way.
No, you can't. So what you can do, for example, in Celestia, so you can have a trust minimized bridge between 2 different rollups on Celestia, but you can go back and forth from Celestia itself. So for example, if you're using a TIA token, for example, and you want to bridge it to a rollup and back to Celestia in a trust minimized way, there's no way to do it currently.
Unless there's ZK. And that's why they might enshrine the ZK verifier into the protocol.
Yeah.
Okay. And is this fundamentally different from like the light clients that are verifying the data availability via data availability sampling? Is that what you're talking about enshrining into the protocol, or is that a different form of verification that happens on the system?
So I'm not sure if the lifelines would do the verification of the proofs, because currently they don't do verification of execution. As far as I know, they only verify the data availability and the header correctness. So I would assume that at least the full nodes would be doing that. I'm not sure if they would add that to a lifeline or not.
Yeah. So is something then, and I'm going to keep coming back to this competitor question, but is something like Avail, which has like these KZG commitments and has ZK already like baked in from, or theoretically on mainnet, that's more of a monolithic chain than like Celestia is pre-ZK.
I actually don't know if Avail allows you to verify ZK on chain, so I'm not sure where ZK comes in there. But if they did, let's assume that they do for now. I would say they are, but like I would also say that all of the chains to a certain degree are competing with one another, even if they're not right now and they're targeting different things. I think long term the paths are converging. It's just a question of how you achieve it. Do you achieve the modular way, like the way Ethereum is trying to do it, or do you take the Solana approach and like put everything into one protocol?
Yeah. So people, when I put this tweet out about Celestia being the biggest competitor, people were asking me like, "Oh, is it about cheap DA?" It's like, yes, it's about cheap DA in the sense that like Ethereum's going down this DA focused roadmap or this data availability focused roadmap. But it's really about this validity and this ZK kind of settlement angle, where if I'm going to use, Celestia or other DA provider for my data availability, and then there's also some sort of consensus baked in using ZK verifiers, then the question becomes like I'm a roll up, but I'm no longer like an Ethereum roll up. I'm just a roll up on Celestia or roll up on this data availability and consensus layer. And I have my execution on my, maybe I use EVM still, or maybe I use a different virtual machine.
Yeah. So I think people, when people see Celestia as an Ethereum competitor from the perspective of DA, that I don't see Celestia as a direct competitor, because no rollup building on Ethereum is gonna choose Celestia over Ethereum for DA if Ethereum had enough capacity. The only reason why people are doing it is because Ethereum just doesn't have enough capacity. And so let's say in a theoretical world where Ethereum has unlimited capacity, but Celestia is not unnecessary for this particular thing. But once Celestia integrates ZK, I think you can start seeing Celestia as more of a competitor for Ethereum in terms of like an L1 that is primarily a roll-up centric L1. Let's call it that, because now you have, as a developer, you have a question: do I build on top of Ethereum or do I build on top of Celestia? Because you can offer the same, or mostly the same features. Celestia will still have a bit of a limited functionality in terms of like you cannot have tokens on L1, at least for now, etc., etc. But like other than that, your functionality is essentially identical. So now your question becomes: do I build on Celestia or do I build on Ethereum? And now you can see that Celestia all of a sudden becomes a direct competitor to Ethereum.
Yeah. And so Scroll is pretty Ethereum aligned. We haven't talked too much about Scroll yet, so I'd like to talk a bit about Scroll. Obviously, you are, Scroll's vibe, Scroll's brand is, type 1 ZK VM, fully EVM compatible, very Ethereum aligned vibe, ethos, and everything. So maybe this is a silly question, but is Scroll modular? Like, is a ZK EVM rollup, is that a modular component of the Ethereum stack? And kind of following up with that is like, are we going to see a world where general purpose L2s like Scroll and others in the ZK space follow like the CDK, OP stack, ARB orbit model to then like go even more modular and scale your L2 in a more like specialized and modularized fashion? So kind of two questions there. Maybe they go hand in hand.
Yeah, I actually don't like the term Ethereum aligned. I think it doesn't really define anything. It's like, is it the most Ethereum aligned person, the person who shouts the loudest on Twitter, or like, how do you define Ethereum alignment? I think if you look from the perspective of L2s, they're always going to be modular because they're outsource at least some of their core security to the L1. So, for example, minimum, you'll always outsource some DA. The DA guarantees to the L1. So you can see how, from the perspective of an L2, you'll always remain modular as long as you don't spin out and become a separate L1. So, for example, the way DYDX did it, then you're no longer modular. But in the context of being an L2, you're always going to be modular. So the question of modularity being a meme is more from the perspective of an L1. And then in terms of, I think the reason why we're building on Ethereum is because, one, the entire team has been following Ethereum's progress and has been inspired by Ethereum in one way or another. Ethereum was the first protocol that I ever used, and funnily enough, I got into crypto through Ethereum, and I'm probably one of the few people in this industry who almost never used Bitcoin. I think I touched Bitcoin twice in my life, and even then it was because somebody had to pay me in Bitcoin. And so, and we wanted to help Ethereum scale, and it was always our core ideology that we think that EVM is the best way to go about things, purely because of the network effects that it has. I always like to bring up this example. So, for example, if you are a programmer from a traditional background, you've never heard about blockchains before, you hear about smart contracts for the first time and you think they're cool. If you Google programming smart contracts, the first 1,000, 2,000 results are all going to be Solidity or EVM. And so while you have SVM and you have Move, which both are great VMs, and in certain cases they're even better than EVM, the gap in terms of the resources that are out there is massive. And there's also a question of, even if you ignore the resources part, how many people can audit Solana Rust code, for example, and how many people can audit a Solidity code that is written for Ethereum? Again, the gap is enormous there. And that's why we think that the best way to reach mass adoption is to work on scaling EVM rather than moving and trying to reinvent the wheel, which I'm not saying that from the perspective of I don't want anybody else to do other things. I think what's SVM and Move VM achieved, and also Cairo VM achieved, is very important, and we've learned a lot from all of them. But at the same time, we just don't think it's the right approach for us.
Gotcha. You brought up a good point that I'm going to double click on because I saw this tweet from Chao Wang today. You may have seen it. I'm just going to read it. He tweets that he sees no reason why leading L2s wouldn't eventually become L1s. Quite funny compared to with your convergence thesis at the end of your talk, or at the end of your slides. And why L2s wouldn't eventually become L1s. They'd be valued by the market an order of magnitude higher, and they'd realize what I've realized by being in the trenches, that dApp builders are pragmatic and couldn't care less about Ethereum alignment. So I'm just going to stop there and maybe just your initial thoughts.
I don't think the reason why builders build on L2s is because of alignment. It's more because it's the easiest way to tap into secure liquidity. And I know a lot of people are going to say that rollups are still multi-sig, but eventually they won't be multi-sig based. And so they're going to have this trust minimized bridge that you cannot have any other way with Ethereum. And Ethereum, at least for the foreseeable future, is going to be a liquidity hub. You can see Solana making strides, etc. But in terms of how much money is on chain, it's not even comparable to how much money it is on Ethereum. And also, again, you want to access the community and the tooling and everything else that comes with that vast liquidity. And so I think for a lot of people, for a lot of devs choosing to build on top of an L2 versus to build on an L1, it's more of a numbers game in terms of do we want to maximize the amount of liquidity that we would like to access? And so the best way to do that is to build on an L2.
Yeah. Okay, so then let's put it this way. let's say instead of going to an L1, your users of ZK rollups, and I know ZK Magic is going to take care of these problems over time, but users of ZK rollups currently pay a bit higher gas fees than on optimistic rollups. Obviously, like pre-confirmations and then full confirmations and proving times are still a little bit are slower than like basically these like fast pre-confirmations on optimistic rollups. But to solve this, you're given a proposition. Okay, Scroll ZK EVM can continue to use Ethereum for DA and use blobs and have higher transaction fees, or Scroll can use Celestia for DA and give their users a much better experience and much cheaper fees. Like, what goes through your mind when you're presented with this like type of trade-off question about, you know, Ethereum alignment or user experience or you know, decentralization? Kind of like how would you think about this?
I think the reason why we didn't choose to build on an LDA solution is primarily because we want to minimize third-party dependencies as much as possible. And that's one of the reasons why I'm, for example, against using shared sequencers for rollups, because it just creates third-party dependencies that your protocol is to a certain degree dependent on. So, for example, what happens if Celestia disappears tomorrow, or any other DA layer that we're using? Now, okay, like long term, there's not going to be a drastic effect, but short term, you would basically have to halt and re-engineer your entire base to work with Ethereum or any other DA layer. And so I just don't see a reason why we would want to introduce that risk to the protocol. I think this, for certain use cases, that's fine. I think if you're building a game or something that doesn't really have value in a sense, that monetary value, it still has value, but it's not as quantifiable as, let's say, like having USDT tokens or your ETH locked in a bridge. And I think for those applications, it's absolutely fine to use third-party dependencies, because even if something goes wrong, you don't have hundreds of millions or potentially billions of dollars at risk of user funds. Whereas if you're building a general purpose rollup, I think your primary focus should be to maximize the security and minimize the dependencies. Even if the costs are not equivalent, we take this risk, but I think over time, the difference is going to become negligible. Obviously, 4844 is not going to be the solution to that, but it's the first step towards getting us to a point where we can say that, oh yeah, you might pay a bit less for Celestia, but it's a difference of like 0.01 cents versus, let's say, 0.005 cents.
If I was to play devil's advocate here, it's that the third-party dependencies are what make a chain modular, and outsourcing that is what potentially increases scale. So when you think about the convergence of modular and monolithic, what do they converge to? Because when you first said that, my initial impression was that they would converge to the point of maximum scalability. But there's trade-offs. And you're saying, the point of maximum scalability might come with third-party dependencies because you're outsourcing functionality to third parties. And as a result, you lose some security benefits. So if you could kind of like consolidate like this convergence point, how would you define like this convergence, this like the point that they converge to?
I think different protocols are going to make different trade-offs and outsource different things. It all depends on your risk profile and how you see things. Because, for example, I bet if you bring in 10 other people who work on rollups or other modular protocols, we all will disagree on what we think is sufficiently secure versus too risky. And so I think from the perspective of Ethereum, I think long term you would see this convergence in a sense that you would have the L1 primarily doing DA plus enforcing validity plus ensuring that you can facilitate communication between different L2s, and L2s taking the brunt of the execution. And so I think that's how it's going to play out long term. I think, again, for certain use cases, you would still use external DAs, and that's absolutely fine for certain use cases. But in general, if we're talking purely from the perspective of general purpose rollups, I think it's inevitable that they're going to try and minimize as many minimize the number of dependencies as much as possible.
When it comes to like trust minimized bridges and minimizing dependencies on third parties, you also mentioned like minimizing dependencies on something like a shared sequencer that may come with interoperability benefits, but may reduce like security. What's the current bridge landscape for L2s and general purpose rollups? Like, what is the bridge setup that Scroll uses, and is that trust minimized?
I don't think, aside again the classic, except for Fuel version 1, I don't think you can say that any rollup has a trust minimized bridge, purely because we still have a multi-sig that can upgrade the bridge. And while I personally consider that safe from my perspective, but that's because I work at this team, so I know like the security precautions and everything. I don't think you can classify it as a trust minimized. A lot of people will not see it as like sufficiently secure to park millions or potentially billions of dollars in. We're taking steps to get there, and I think all the other teams are also working on it. There are certain things that you can do in order to basically push to minimize the trust assumptions as much as possible. So, for example, we introduced two-factor authentication. That's what Justin Drake called it, which is a multi-prover. Basically, it's an SGX prover that runs in parallel with our zero knowledge prover, and basically we only process withdrawals if both of them agree on the same state. And so if one of them attests to a different state than the other, we pause the bridge and then we let the security council. In this case, currently we ourselves, but long term it's going to be the security council who's going to take care of that. And so this is the first step towards what I predict would be the way where you can remove a multi-sig. I think removing a multi-sig and introducing like delayed upgradability will require taking 3 steps. One is having multi-provers. 2 is what I call is multi-verifiers, which is basically you, instead of having one instance of the bridge running on Ethereum, you implement 2 different versions, one in, let's say, Solidity and one in Viper, and then you only process the withdrawals if both of them agree on the same state rights. And basically that eliminates accidental bugs inside the smart contract, because unless there's a scenario in which both of the compilers had the same bug, which resulted in the same invalid state transition, it's highly unlikely that you'll ever get a bug that resulted from an implementation that will cause the rollup to fail. And then the third step, because having a multi-prover and a multi-verifier eliminates the implementation of bugs, but it doesn't really solve the problem of what if the specification of the protocol is invalid? What if you made a bug when making the formal specification? And that's where formal verification comes in. Again, that doesn't fully guarantee that everything is going to work out without any issues, but it's a way to minimize the probability that you actually have a vulnerability inside the protocol specifications. And basically, if you combine all those 3, I think that's sufficient for us to remove the multi-sig and basically have delayed upgrades that either take like a few weeks or a few months to enact. Because basically the probability of us finding a bug that will result in funds being drained would be 0 in this case.
Mm-hmm.
Or not 0, but like negligible.
Yeah. That, just to hone in on that one part about multi-verifier, that piece, that, like, we were talking about Celestia enshrining the ZK verifier into their protocol, which would then give them only like a single verifier that the entire protocol uses. So
Yeah.
at the time, there's actually a lawnmower going outside, which is why I didn't ask the question. But the general ZK question I had is like, why? Like, is there any value in verifier redundancy and having multiple verifiers running on the protocol to help like verify the verifications?
Yes, but it depends on the specifics. So, for example, in Celestia, because they're enshrining ZK, you can make an argument that, like, if something is wrong with the ZK, then essentially you can just, with the verifier, you can just like stop the chain and roll back because the entire chain becomes invalid. You can't really do it on Ethereum right now because the verifiers are not enshrined. So every chain, every rollup has a different verifier implementation, etc. And the reason why I think it would be difficult for Ethereum to actually implement the verifier is primarily because, one, there's a diverse set of verifiers, and two, there's a diverse set of programs that we're proving on those verifiers. And so essentially, how do you even converge that into one big program and one big verifier that you accept as a general purpose verifier to work with everyone, to work with all the rollups?
It's a good question. I don't know.
I don't know. I don't think anybody knows, and I think that's the difficulty. So Ethereum can choose to enshrine, for example, one verifier for a specific ZK VM or something like that, but they cannot enshrine every single verifier, because that'll mean that when now people complain that upgrades take too long, like half a year or a year, that'll mean that upgrades take 5 years or like something ridiculous. So I don't think any of us would want that to happen.
Yeah. I guess I just have one more question, which is on like the bridge side of things. Like, is the reason that Scroll has like a quadrillion ETH in its like block explorer because it has this multi-sig setup?
No, it has nothing to do with the multi-sig. It's just the way the L2 was designed and the way we designed the L1 to L2 messaging. We kind of had to do it because you can either do it through a mint and burn or just basically do it in a few other ways. And we basically made a decision that this was the most straightforward and the most secure way of doing things. But I know it looks scary when people go to that smart contract and see I don't know, I think it was like 5 trillion ETH or something like that.
It's like more.
Oh no.
It's more ETH than like is in the circulating supply. So it's just funny. It's a funny number to see.
So the reason why it's this large is because we just like protected ourselves in case everyone goes insane and let's say says, oh yeah, we'll just multiply all the ETH in circulation by 1,000 or something ridiculous like that, or say like we're gonna mint 1 trillion ETH every year via block rewards. So the reason why we made it this high is so that there's no chance that the supply will ever exceed that much.
Is it not an upgradable contract where you could mint like more on that contract if the ETH supply system suddenly changes?
Technically, we could, but that would result in us basically making changes that might lead to some compatibility issues, etc. So we would like to minimize the amount of changes we make as much as possible. But yeah, I think again, I think eventually it's a UX problem, because unless you look at that smart contract, you'll never know that that's that actually is a thing. And so I think we'll just eventually work with the block explorers to ensure that they don't display that number, because it doesn't really matter. Like, it's just there in the back end.
And so that ETH, that large amount of ETH is just locked in that smart contract until, and then when someone bridges to Scroll, that smart contract releases some of that ETH.
Yeah.
Okay.
So you can either do that or mint every time you basically burn a mint, or like not burn and mint. You would lock on Ethereum side and then mint on Scroll side. But there are certain things that basically would have made the implementation a bit more difficult, and so the decision was made to just do this.
Okay.
I know someone made a tweet. I think it was Dom from EF made a tweet that if Vitalik bridged all his ETH to Scroll, and people actually took it seriously, thinking that Vitalik had that much ETH in his wallet, and people were like, "Oh yeah, congrats, Vitalik is supporting you guys." I'm like, no, I wish. That's not how much TVL we have on chain.
Yeah.
DeFi Llama would have another thing coming.
Yeah.
I don't want to make their life even more difficult. It's already difficult as is with the number of chains and with the number of protocols that they have to support.
Yeah.
Yeah, definitely. Well, Togruhl, thank you for coming on to Modular March and sharing a really interesting, refreshing presentation and conversation. It's been a pleasure to have you, and really excited to continue to see Scroll's growth and also the interesting topics that we touched on today, and just keep close tabs on the evolution of this convergence of these different architectures kind of converging into a similar point. So again, thank you, man.
Thanks for having me.